our approach was LayerZero is not a blockchain. It's an immutable set of smart contracts, libraries, really like a TCP IP library that lives on your computer on every single blockchain. Then any issuer, any asset issuer can basically deploy and run those rails themselves. So if you look at some of the recent assets that went in production over us, like BitGo, WBTC, right? So they moved WBTC is like a $10 billion asset. Rather than delegating that security out to other third parties, they run a part of that security themselves. Same thing with USDT Zero. Same thing with many of these others.
Welcome to Tokenized, the show focused on stablecoins and the institutional adoption of real-world assets. And we've got a great show today. My goodness, we are interviewing Bryan Pellegrino, the CEO and co-founder of LayerZero. I am, of course, your host, Simon Taylor, author at FinTech Brain Food, head of strategy at Sardine. And joining me, as always, is Mr. Cuy Sheffield, head of crypto at Visa. What's up, Cuy?
A lot is going on. I'm excited to get into this topic. I think interoperability, cross-chain bridging, how do we demystify this world for our audience? Let's get into it.
Bryan, welcome to the show. Thanks for joining us.
Thank you so much for having me.
All right, before we jump in with you, I just need to remind our audience of something. Tokenized is also brought to you by Avalanche. Major banks, fintech challengers, and industry leaders are using Avalanche to create new business models on a fully customizable blockchain infrastructure. Think of it as more than a blockchain. Think of it as an entire network built for financial institutions to innovate. With purpose-built layer ones, institutions can tailor digital asset strategies to their exact needs while still tapping into the power of a public blockchain, innovation, developer communities, and seamless interoperability. Join the institutions shaping the future of finance on Avalanche, and you can learn more at avax.network. All right, Bryan, thank you so much for being with us. Let's just start with some super basic stuff, right? There's a lot of talk about interoperability between blockchains, between everything. It's just that buzzword that you see everywhere. So can you define interoperability between blockchains and other things and kind of the various approaches that are kind of out there?
Yeah, sure. I think my mental model is, it used to be actually quite difficult for two computers to talk to each other. So surprisingly now, when everything is so seamless, that wasn't actually a super easy thing. And so you used to have these isolated, distributed execution environments. You had Stanford, you had DARPA, you had, all of these different environments. If you wanted to run some data or program you literally would take a floppy disk and fly to Stanford and put in a computer and do it. And then we invent this cool protocol, TCP/IP, and now everything can talk to each other and life is good. That's how we talk now. That's how we do everything today. And it's just in the background, you don't ever think about it. Even computer science students barely learn about the networking stack anymore. So OSI model is out. It's just fully abstracted. You move a couple of years ago, so 2021, when we really start working on this fully, and everybody in the space was talking about bridging. That was a thing. And typically these were through third-party providers who would lock up your asset here, and then they would, in some fashion, mint you a representation, some wrapped asset on another chain, and you sort of carried that provider risk. And we had $4 or $5 billion worth of hacks through this structure because the person responsible for doing this had some lapse of security. And so our original insight back then was, listen, bridging is just a special case. Value transfer in general is just a special case of generic messaging. What we care about is making a protocol for purely generic messaging. So think about it like you think about a packet on the internet. It can be any data, it can be anything. And if that happens to be value, great. That's just a array of bytes that you basically include in this. So that was the original vision. Recreate TCP/IP across these distributed execution environments, which is really what a blockchain is. And so when you get to the different models, the one model that almost everybody did in the past was you'll have what I call a middle chain. I will make a chain. I'll have a set of validators and some stake in that chain, and everything will flow through that as a central hub. So hub and spoke model. And that's a really nice dream to connect everything and have everything flow through that. But it's really, really hard in reality when you're going to connect hundreds of billions or trillions of dollars of assets to have all of that secured by one central hub. If anything happens to that, they can take everything, right? So you can imagine every bank, every ledger that exists in the world has the ability to be corrupted by that thing being corrupted, even for a matter of blocks. And this can be a client issue. This can be an actual security, like 51% attack. This can be a whole array of different things. Short answer is always no. There is zero chance in the world that the future financial system is going to delegate 100% of its security to some third-party validator side. It's just very unlikely to happen. So our approach was LayerZero is not a blockchain. It's an immutable set of smart contracts, libraries, really like a TCP IP library that lives on your computer on every single blockchain. Then any issuer, any asset issuer can basically deploy and run those rails themselves. So if you look at some of the recent assets that went in production over us, like BitGo, WBTC, right? So they moved WBTC is like a $10 billion asset. Rather than delegating that security out to other third parties, they run a part of that security themselves. Same thing with USDT Zero. Same thing with many of these others, Ondo. It allows them to actually own their own security. And if you want to backstop that by including some other groups, sure, we have 45 groups who run security now. Google Cloud runs it. You have ZK Light Clients, the full technology stack of providers. And if you're a small asset and you just want it to work, great. You delegate to any of the external parties who do this professionally, and they can have stake and they can have all these things you would want. But if you're a bank, if you're a financial institution, if you're any of these things, you can imagine this allows you to create your own CCTP, circles methodology for moving yourself. Any institution, seamlessly, you own that, and you don't need to actually, again, our contracts now have been in production for 3+ years. There's $240 billion worth of asset issuers building on top of them, about $100 billion of actual assets deployed and $75 billion transferred over the rails. Immutable, we cannot change them. Nobody should ever need to trust us or have any delegated authority to us. It is a protocol in the truest sense, a piece of technology that exists, and it allows asset issuers to easily and credibly have full control over those rails if they want them, or delegate any piece that they want.
A ton of interesting concepts there. I want to take a step all the way back, even getting to like, what is the problem that ultimately this technology and stack solves? And so I like to start with one of my biggest pet peeves that I've had for years now. When I talk to institutions about blockchain technology and crypto, is whenever I hear anyone use the term the blockchain, like we're just going to put it on the blockchain, and I'm like, oh, like the blockchain, like it's, if only there were just like this one thing that like everyone agreed upon, everything would be super easy. But it's not the blockchain, and so there are actually many different blockchains. I think one question is, how many blockchains will ultimately be successful? I think today we see, dozens of blockchains exist. There are probably significant activity on maybe half a dozen. I don't know how many you would say, have meaningful activity. And so if I understand you correctly, why does this matter? If you're an asset issuer, whether you want to create a stable coin or a tokenized security, a tokenized bond, money market, whatever it is, one of the first steps and questions is, which blockchain do I issue it on? And it feels like the answer today is it's hard to choose one. If you choose one blockchain, you're kind of missing out. What if you choose wrong? What if the other blockchains that have different properties, you scale and get adoption of that use case? And so it seems like asset issuers are saying, we want to issue multi-chain. But then if you're issuing multi-chain, how do you do that in a secure way? It seems like it's more work, more complicated to issue multi-chain. And then once you have an asset that's issued multi-chain, how do you enable a consumer who's got USDC on Ethereum to be able to move that to USDC on Solana? And so is that the right way to think about it? And so is the framework that our audience should start with is, anyone who's in the position to issue assets probably wants to issue multi-chain. And then how does LayerZero specifically make it either easier to issue multi-chain in the first place, or once assets have been issued multi-chain, make them be able to move between each other? Is that the right way to think about it?
Yeah, I mean, in my mind, every asset issuer has a singular goal, which largely is usage, is TVL, is AUM. Like everybody wants to, just like a business wants to expand its customer base and wants to expand what it's able to do. And so if you talk to from the largest, from the BlackRocks and Apollos who are issuing on-chain now, every single one of them wants more. They want more exposure for the underlying asset. They want more customers to be able to access this instrument in a way that's compliant with what they're doing. And so, if you issue only on Solana, well, you're missing out on a couple $100 million worth of latent capital that's living on Ethereum. If you issue only on Ethereum, you might be missing out on something on a different chain. And so most of them want to be multi-chain because that just means more usage, and more usage should generate more revenue, more, everything that sort of they're looking to do. And so then the question is, how do you, one, make that very easy to issue? So we have this standard we call the OFT. This is where that $100 billion is largely issued across this standard. You can think about it like ERC20 on Ethereum. It's just a single standard. You use it, and inside the token itself, it allows messaging to any of these other chains. And you choose what you enable, you choose the security model, you choose all of these things as an asset issuer. So on that standard has made it very, very easy for a lot of people at scale. So going multi-chain itself now is that part is quite easy from the first step. But what you really want to enable for most of them, especially as we get to more sort of real world adoption here, is the end consumer needs to not feel it, right? If you're, like you said, if you have USDC on Arbitrum and your merchant that you're spending with or thing you want to do lives on Solana, the prior method was you're going to write a transaction here. You're going to wait for 10 minutes. You're going to have to claim your transaction over there, which means like now you got to find out how to get Solana when you've probably never done it before. You're just a user. You're not thinking about this. You got to go to a centralized exchange, send it to that wallet, claim it. The goal of LayerZero is like, listen, the user is going to click one time. There's going to be a bunch of embedded fees. Post some of the new EIPs. It's actually the users can pay directly in stablecoins. They won't even need to have underlying gas. Right now, you need to have gas on the chain you're on, so on Arbitrum, on Ethereum, on whatever. But one transaction, whole flow is executed. The user never sees. It can jump across 7 blockchains. It can execute 10 different smart contracts. The user never sees that. They're billed one upfront cost of what is the gas going to cost on all of these. They click it. Everything happens in the background and it's done. It's dead seamless. And I think that's what you need to be able to do. And even more right now, the latency for that, median latency is you can have outliers of probably 10, 12 seconds, but median time is about 29 seconds, at least between L2s or some of the major networks. Some of the networks are a little bit faster, some are a little bit slower, but that's median time as a whole. Obviously, that needs to go down into like single second, sub-second ideally. There's a lot of work that needs to be done there to really have this really seamless abstracted consumer experience. But the goal is, just like when you do anything today, this platform that we're using to record this is talking to servers all over the world, each hyper optimized to do a specific thing. One might be optimized for storage or database. And you have all of these different pieces that are coming together to make this seamless experience. Again, a blockchain it's very easy to make it this abstract concept. It really is just a bunch, it's a distributed execution environment. It's a bunch of computers that all just are doing the same thing. And those computers are tuned to do something specific based on how the VM is. And so you really need to orchestrate that really nicely.
I really like that practical example of, I'm a consumer, I want to buy a thing, I want to hit the checkout button and I want it to just work. And that's kind of what I expect today with cards and, a Visa auth. If it takes longer than half a second, people involved behind the scenes are like jumping up and down with their hair on fire. Like, this has got to happen quickly. And with blockchains, you don't want to see all of the wires. You don't want to see all of the hops as a consumer. You just want it to happen, and it should. So you're kind of helping that happen there, and the wallet experience gets better. But from an asset issuer standpoint, it struck me that was it yesterday, as we record this, the CEO of Bank of America said, if and when regulatory clarity comes, they will, of course, move in to seek this opportunity. An organization of that size doesn't want to be issuing assets on every single network and ledger. So having a single standard that they can do that with makes a ton of sense. Could you contrast OFT and your standard approach of kind of messaging to some of the other sort of cross-chain solutions that are in the market. There's Axelar, there's Wormhole, there's others. Like, help me like differentiate LayerZero from some of the other approaches in the market.
Sure. So as I described in the beginning, both Axelar and Wormhole have taken the approach of we're going to be this hub and spoke model. So Wormhole, they have 19 validators, and they say, hey, these are our trusted 19 parties that we've assembled. You can think about it as a proof of authority system. And everybody who interacts with this is going to rely on that set of 19. So it doesn't matter if you're JP Morgan trying to transact with Goldman Sachs, or if you're some user on Ethereum trying to transact, a meme coin or an NFT or any of these things, everybody is going to rely on the same set. Same thing with Axelar. Axelar is a permissionless set, so anybody can be one of those validators, but they are the hub and spoke model. So the issuer doesn't actually run their own security. The issuer does, they can join and be one of 75 or one of, 19, or they can't be one of 19 in the Wormhole case, but they could let them into that if you're a big enough issuer. But that's really it. They have a hub and spoke model. Originally, they were issuing wrapped assets. So it was like, hey, we're gonna lock it here. We're gonna have $5 billion locked in this chain, and we're gonna have $5 billion minted over that. But that really changes the relationship for the user with the asset. So if you think when a user uses Uniswap or uses any product, right? They're using some smart contract, some code. So there's some embedded risk there, but it's been battle tested for a long time. And the user clicks the button, it happens. And as soon as the transaction is done, they never think about it again. There's no carried risk by the user. They have their asset, they go on their way. When you have a wrapped asset, what that means is if at any point in time, the user doesn't have a real asset, they have an IOU on another chain, right? And so if that contract on the destination chain gets broken or hacked, that asset is worth nothing. If the underlying contract where all the assets are held originally gets broken or hacked, that IOU now has no backing. It's worth nothing. If the middle chain, the consensus mechanism that is like controlling this in Axelar's Wormhole case, if that ever gets hacked, like I said, even for a matter of a couple of blocks, they can arbitrarily write the most malicious state to every application everywhere. So it really was just a fundamental difference. Our belief was that all the largest institutions in the world are never going to hand over their security to a third-party validator set, period. They will want ownership and they will want to run it themselves. And if they don't, then great. You can still delegate it. You have all these groups. Actually, in the LayerZero model, we have some issuers. So Ondo, for example. Ondo uses Axelar through LayerZero as one of their validators. So LayerZero as a framework allows you to use one of these networks that they've created to provide your security while not necessarily using kind of their framework, or you're using only that. So for us, we're totally agnostic. You can fit anything in at that validator level. Yeah.
Yeah, what does it actually mean as an asset issuer to provide your own security? Because I get the idea that if you're outsourcing it to someone else, that's another layer of risk. I also get the idea that the early concepts of bridging, where you lock on one chain and you issue on another chain, it is in IOU, and particularly with a stablecoin or an asset that's held off chain, now it's like this whole nother abstraction. So you've got fiat in a bank account, and then you've got the kind of native stablecoin issued on one chain, and then that's locked there. And then you've got an IOU on a second chain for the stablecoin on the first, and you start to see how like each one of those layers is additional risk. So those concepts make sense. In your model as an asset issuer saying, I want to provide the security myself, what does that mean? Does it mean I'm actually redeeming or burning an asset on one chain and minting it on the other one, so it's never locked one place and then at IOU another? Is it you're actually removing the asset, it gets eliminated from Ethereum and it gets minted on Solana? Is that the way to think about the mechanism?
Yeah, so that's the way OFT works in general. So all OFTs work in that structure. The difference is if you looked at Circle pre-CCTP, what they would have to do is you would have to say, I'm going to redeem this USDC. And you would burn it in some smart contract in Ethereum. You would wait some amount of time. They would have some centralized process for going through and saying, okay, we're going to process these. And then you would have to say, okay, I've redeemed. Now I want you to issue me new on Solana. That might take like hours or days or like, this very long time period to actually do that process. And it's a very manual process. And so they went through and they created CCTP, which is, hey, we're going to, you already trust us, Circle. We have your stable coins in banks and treasuries, and you trust us to hold that part. We're already doing this in this manual process. We're going to create an automated attestation, which you will burn this. We will sort of be listening for those events, and we will provide the go signal on the other chain to mint it. So they've automated this flow. They own the security. They do all of that. That's exactly what it is in the LayerZero case. Like Circle could do that now on top of LayerZero instead of doing it themselves. So they had to build all of the rails and the infrastructure and all the hard stuff to do that, rather than just say, here's my sign off, right? Like the easy thing. So new smart contracts, new everything. With us, it allows you to, one, be that level of I must sign off on this, but you also can backstop it with others. So let's say you're a new asset issuer and you're launching a stable coin, and you say, great, listen, I definitely want to sign off on everything I do, but I'm also a little bit like, I'm new to running infrastructure for all of this stuff. Maybe I don't want to be the only singular point of security. I've seen all these hacks. I saw the Bybit hack. I do everything. Now you can also, with LayerZero, you also have Google Cloud sign off, and you also have, you pick the groups that you want, and maybe you say, hey, I want these 3 out of 5 to sign off, and I must always be one of the 3, but I also want to be backstopped for the others. So now the user, or even you as an asset issuer, say, hey, listen, there's the only thing that can happen is I must be hacked and compromised, and Google must be hacked and compromised, and one of these other groups must be hacked and compromised. And the coalescence of all of those 3 things end up being quite a strong security guarantee.
Yeah, it's fascinating. The having worked with financial institutions for a long time, I know they will not want to outsource security, and I know they won't want to give it to a particular place, and they're going to want to kick the tires on it. And it's a thing that you see every time there's a headline like Bybit, as you mentioned. The sales pitch internally for moving into digital assets gets that little bit harder, but really making the case that you can use security models and best practices that you have today, and you can apply those further out, I think is comforting for everybody to kind of understand, and that you could take the ability to issue assets and to create digital assets, back them with the treasuries you hold, back them with the deposits that you have as a financial institution, and bring that liquidity into the space is exciting if you are looking to move into stable coins. Because the first question is going to be, is it compliant? Well, it helps that we might get regulations. Is it going to be secure? But I want to move us to stable coins because they are like the topic du jour at the moment. And you've announced a multi-chain version of USDT Zero, which is with Tether, and it's going to debut on Kraken's Layer 2 INK, I believe it's called, and it's launched in a couple of places. But Kraken chose to implement this rather than launch their own stablecoin. It feels like everybody's launching a stablecoin these days. Everybody's having a go at it. What do you think the rationale for that was? And what do you think's starting to happen as a result of some of the interoperability? You have a unique vantage point on the market.
Yeah, I think when it comes to stablecoins, if you look at basically every major stablecoin in production. So again, Circle runs their own, but you're talking Athena, USDE, SUSD is about $16 billion as an asset total. Ondo, PayPal, PYUSD, USDT, all of these things, right? All of these are solutions that are now, have solutions built on top of LayerZero. And so there's a couple of things that are really unique. One is our pitch typically to these stablecoins is, listen, one, you want the maximum velocity of your stablecoin. You want maximum utility. You want it to be used in every market in the world that you possibly can. You want it to be as frictionless as humanly possible. You want it to be able to be rebalanced easily. In the current state of the world, the previous state, to even move USDT, you're talking 6, 8, 10, 12 bips if you even had a pathway. A lot of them didn't. You have to go out to a centralized exchange, and you have to wait this time, and then you have to come back out to try to get them. And they're dealing with inventory issues on the back end. Now you look at Kraken's Chain Inc. They moved $80 million worth of USDT to USDT Zero, and it cost, I think, something like $1.50, right? You can move unlimited. There is no bips. It's not for us, everything is a generic packet. We don't care if you're sending 1 penny or $1 billion. You can move $500 million for just the cost of gas. If you're going between Solana and Arbitrum, you're going to move $500 million for a fraction of a penny. And so the ability to do that, now you think about, okay, now movement between these chains, rebalancing becomes totally seamless in the background. And again, with latency constantly decreasing, now you're talking spreads between chains can be arbed within like sub-cent spreads. So now you have much more liquid markets. You have much tighter spreads across all of these different disjointed markets that are happening. And it just becomes an actually much more useful, net useful tool as a piece of currency that than could exist before. And that usually is a thing. Like, that's very exciting to asset issuers. And I think you see it now with, with USDT, we've seen really large transfers happen for basically zero cost. And there's the same thing across the board with PayPal, with Athena, with all of them.
Yeah, so I want to unpack this Kraken example a little bit more to make sure I understand it. And so I think the first piece, so Kraken has created their own layer 2 on top of Ethereum, which is called Ink. I think it's using the Optimism, OP stack. We're seeing this as a trend where you've got many institutions, whether exchanges, even some traditional companies. You talked about Sony in the past, as they're creating their own L2 that they've announced, and so there are more and more of these L2s that are coming online. If you're the asset issuer, Tether in this case, part of the question is, okay, are you going to issue USDT directly on every L2 that exists and emerges? I imagine that that requires some real work. Every time you want to natively issue USDT on a new chain, you have to, my understanding is you have to have a smart contract, for that chain. You have to make sure it's audited. You have to, have the node infrastructure for that chain. You have to have everything, for that chain. And I think today USDT might be on 8 chains or so. I think Circle's on like 16. And so I think Circle has gone the farthest. And there are other issuers who are taking the approach to go even further. And so in the Kraken scenario, is this USDT is issuing on Ink the same way that they issue on Tron or they issue on Ethereum, and they've decided to add Ink as another network? Or are they using LayerZero, basically saying it's just hard for us to keep up and add all these other networks? And so here's a way that you can move from USDT on Ethereum to Ink, which is EVM compatible, without the asset issuer having to do a direct integration and understand all the unique properties of that network. Is that the way to think about it? It's like the process of getting on a new chain, that's one barrier. And then how to move between chains is the second. This is trying to solve both at the same time, where for the first time USDT is on Ink through this mechanism, and it's on Ink because it can move between Ethereum, Ink, Tron. Like, it is any chain that USDT is currently on can be bridged, and I don't even know if you use the term bridge since it's different than the kind of normal bridge idea, can go over to Ink. Is that the way to think about it?
So any chain that LayerZero is on is connected in a full mesh. So we're on 122 chains, so most of any interoperability provider. And so all of those 122 chains are connected to each other. So at any point in time, first of all, you're absolutely right. All of the asset issuers, USDC, USDT, all of them, it is incredibly difficult to go to new chains, to new VMs, even to EVM chains that are the same. There are huge hurdles.
There are new ones like every day. It's like, it just happens so much. It's like, how do you keep up?
But at the same time, there's a huge incentive for being there first, because if one of these chains takes off, Bearer chain just launched, there's $3.1 billion got on the chain within the first 2 days. And so do you want, like, that $3.1 billion is getting paired on these DEXs and in these liquidity pools against an asset? And certainly as an asset issuer, you want that, especially as a stablecoin provider, you want them to be paired against you. Every single one of them is ETH2, USDC or USDT, right? Bitcoin 2, USDT or USDC as the pair. And each one of those are sort of, each one of them want it to be them, because each one of them means an extra, billion to 1.5 billion, effectively half the LP pair in their asset. And that just means more assets in total, more AUM, and that's the business that they're in. And so being able to move quickly to any new network on day one, to be the first thing there that is available for everybody to have liquidity into, to pair those liquidity, that's very hard to unwind later. If you have $1 billion of assets that are all paired against USDT and all of the consumers on that chain are already naturally using USDT to trade, well, if you're USDC and you come there, 6 months later, it's going to be very hard to get everybody to swap over to using USDC now or migrate all of those pairs away. And so really there's a big advantage to being able to be there fast, to be day one on a lot of these chains. And I think that's something that we provide to a lot of these asset issuers that is just extremely attractive.
I can certainly see that. Like, if you're in the AUM game, you got to get that AUM. But if you are more institutionally focused as well, we talk to a lot of financial institutions. How do you get them comfortable with the compliance side of being multi-chain? There's the security side, but compliance is like its evil twin.
100%. So we had to go through this, and again, each asset issuer kind of has their own compliance process. But we, via PayPal, PYUSD, obviously working with Paxos, you had to go, full NYDFS approval, and you have to get that for every chain that you're going through. And there's like a very heavy compliance process that goes to it. And so for them, they start on one chain and then they move to another. So there's Solana and Ethereum, and that was this long process. And they will very likely go to other chains in the future, and they're going to go through their own process internally to do that. And we are just the tool that they use. Every new chain that they add will add this connected layer between the three. So now you move between Ethereum and Solana, PYUSD, you're moving with LayerZero. You won't know it, right? It'll be totally in the background, but you can seamlessly go between them. If they add Ink as another chain, now you move in a triangle in any direction you want. And so for us, the compliance piece really is on the asset issuer. We are a piece of technology in the underlying. And so they go through their process and then they just turn it on with us.
Is part of the compliance piece that the issuers look at, whether or not KYC happens at the interoperability step? Because today, traditionally, again, if you wanted to move from, USDC on Ethereum and kind of pre-CCTP, the Circle cross-chain transfer protocol, if you wanted to move from USDC on Ethereum to USDC on Solana, the most secure way to do that would be through a centralized exchange. So you would go to Coinbase or you deposit USDC on Ethereum, and then you withdraw USDC on Solana. That would take some time. Coinbase would have to manage inventory. You would have to be KYC with Coinbase. My understanding is now with CCTP, that's basically just like a low-level protocol kind of DeFi infrastructure where you don't have to go and onboard with an exchange. Anyone who's holding USDC in a wallet on Ethereum, self-custodial, could move that to USDC on Solana without needing to kind of onboard and go through the full process. When you talk to asset issuers today, which approach are they taking? Are they saying, the interpretation is, someone is holding their existing asset, that person is just reformatting which database that asset's on, and so that doesn't require a direct onboarding interaction KYC? Or are some of them saying, no, if you're going to change which chain you're on and you're ultimately relying on our trust, to do that, because we're the one that's verifying that transaction, it's not just a decentralized blockchain. It's like, we are letting you move from USDC Ethereum to USDC on Solana. And if you're someone who, shouldn't have that USDC, and we're now saying that you can move to Solana, like we're then, approving that transaction. And so what are you seeing in that split on the issuer side? Are there some that are requiring KYC and some that don't, or all of them aren't requiring KYC and they're just seeing it as a low layer, database transfer?
On the issuer side, none of them do on a per transfer basis. So they all do this in a way that I'll call reactive fashion. So all of them are very quick to respond. Well, actually, some are more quick than others, but all of them have a method for responding to OFAC, to sanctions, for any of these things. So there's a public list, a blacklist. They have the ability to brick these addresses in the contract. So as these sanctions lists are updated, or is there somebody who should not have funds or should not be able to use the protocol, they will brick them. Those funds will then be frozen or reclaimed. They will not be able to move with that. But it's a constant process of sort of adding to this list. So you can imagine it as a check before it goes out, right? None of these people who shouldn't be able to move the asset can move the asset, but there isn't this full KYC step in terms of every asset. So everybody who's not on this list basically can move freely. Now, from LayerZero's perspective, everything's an arbitrary packet, which means an asset issuer, they can add full KYC restrictions into the underlying. They can add rate limits. They can add, anything that you want to add. Anything that you can do in a smart contract, you can do with LayerZero. Totally agnostic to us. We are just moving the bytes. But in terms of what's actually in production, everything is this I'll say kind of reactive. It's proactive if you're already on the list. But if you had moved it and then somebody realized after, they would then need to go and add you, and then you wouldn't be able to move the next hop.
It's much more institutional focus as I think about it from a global transaction banking standpoint. It's that way. It's like the flow is happening via me, and I'm sort of watching it and making sure I'm picking anything out. But the endpoint should be KYC'd, or they're same as cash. They're self-custodial. Yep. It's the way to think about it. You also, the Telegram Ton network is integrating USDT using LayerZero. It's a pretty big network, but they're also interesting because they bridge this like isolated ecosystem back to the crypto world. Were there any technical challenges with this one compared to some of the others? And could you take us underneath that?
Yeah,
I'd remind everybody Telegram Ton and what that does, because maybe not all of our listeners are familiar.
Yep. Telegram obviously is one of the most used messaging apps in the world. There are about 900 million active users, right? And so as an ecosystem, they've launched their own blockchain, the Ton blockchain, that's integrated into this messaging app. That makes it one of the most compelling ecosystems that could exist, right? You really have distribution downstream into potentially almost 1 billion users. And so obviously there's very strong desire to be the stablecoin of choice within that ecosystem, to have users paying, creators getting paid, all of these things, all of this transactional activity happening and economic activity happening on that platform to be happening sort of through this asset. And so already USDT was there. So I think it's their third largest. I think you have Ethereum and Tron, which you combined for about 136 billion or something. And then I think Ton is about 1.5 billion or 2 billion. And so they had issued an isolated instance there, but there was no way for them to go. So in part of doing Ton, the network, we deployed this USDT native bridge that allows you to move seamlessly between any of these assets. But in terms of building it, any new VM, so for us, again, one stance that we take, you talk about differences in protocols. Another stance typically other protocols have is that their contracts are upgradable. So they can, if they wanted to be malicious, they could be malicious. Even if they wanted to be benign, a bunch of the hacks that have happened, most of the hacks, actually, very few hacks of the $5 billion bridge hacks that have happened because it was actually the bridge operator themselves being malicious. It happened oftentimes because somebody pushed code. So Wormhole, you mentioned, Wormhole had they had a $350 million hack that happened, but then they had a $1.8 billion that was exposed risk that was found by a white hat. And then another time, 2 weeks later, $1.8 billion at risk that again was found through the same issue. And this was not due to anything other than an engineer that was deploying a smart contract forgot to initialize something. In other cases, the case of the Nomad hack, it was downstream. They pushed code that they thought was good. There was a bug in the code. And so our stance has always been fully immutable. You will never need to rely on us. We cannot upgrade it. You don't need to trust us. It is a piece of code that exists. But what that means is when you're dealing with tens of billions of dollars of assets built on top of it, tens of billions, hundreds of billions of dollars of economic activity happening, there's a really large sort of burden in getting that right. So it's really like a measure twice, cut once thing. And so we have to go very deep in any new VM that we're deploying because once it's there, it's there. And so I think we spent almost a year on Telegram, on Ton, building that. We literally rewrote an entirely new programming language, Fun C++, on top of their Fun C. Really, really, really deep technical work. I don't think anybody else outside of their core team has done. And we worked very closely with the core team throughout. So it was a very large lift. It took much longer than we expected. But now that we're there, we're super excited to be there. Obviously, you have the USDT moving around pretty actively. And then we have every other large issuer now wants to get to Ton, and we're really the only way to do that.
Yeah, I want to switch gears and talk a bit about your business model. And I think it's really interesting. You're a protocol, but this is crypto, and in crypto protocols, have business models, and they have ways that they make money. And there's this concept of fee switches, and that we're hearing more and more about, which I want to unpack. So let me just start with how do you make money today as a protocol? Where are the fees charged? Where do they go? Is there a token? Is there governance? Like what? How do you explain that to someone who's never really looked at a protocol as a business before?
Yep. So it's very important to separate out LayerZero Labs, which is our equity entity, which is the entity I'm the founder of, and LayerZero, the protocol, right? So LayerZero Labs, we view ourselves as you would view Consensus's relationship to Ethereum, right? Consensus has a very large stake in Ethereum. They're very vested in the future of Ethereum being successful, and they build products that they themselves monetize that are accretive to that ecosystem as a whole. So they build Infura and they build MetaMask. And MetaMask makes, $400 million a year. And they build all of these things that make Ethereum as an ecosystem have really contributed a lot to its success over time. LayerZero Labs' goal is the protocol doesn't care about us. It doesn't know that we exist. It doesn't give us a tithe. It doesn't know nothing. The protocol doesn't care about us as an entity. We care very deeply about the protocol. And so our goal is to build things that are accretive to the protocol. So one thing we've built is this executor. I described before the natural stance for protocol would be message here, wait, and there's some verification, and then the user has to go and claim the message there. That's just like horrifically bad as an experience. What our executor does, and anybody can run an executor, so permissionless, there's no special privileges for us, is basically say, hey, here's what it's going to cost on Solana. You're on Ethereum. You're going to pay us in ETH up front. So maybe you're paying $1 on ETH and a penny on Solana. You're going to pay us, $1. It would be $1.01. Maybe you'll pay us $1.05. And then we're just going to execute the transaction on your behalf. So you as a user, you click, you sign once, you trigger the transaction on the other side. So LayerZero Labs has done probably at $1 billion of that, of gas from one chain for gas to another. So you're quoting n-squared pathways in real time, and you're dealing with vol and duration risk from the time that you're accepting a quote to paying out. So you're eating losses a bunch of times because vol has basically made pricing on the destination chain move again. So you're doing all this really complex stuff and managing, honestly, $40-50 million worth of gas assets across 122.
So is it like FX for gas? Is that the way to think about it? It's like you're running almost, an FX desk, but it's you've got native currencies being used for gas on both sides that you have to figure out how to hedge.
Now imagine you need to run a full node for every country and every currency, right? That's the other complexity, right? Is we have to run full nodes of all 122 of these networks for $50. So this is like a really large lift from that side. So that's LayerZero Labs, and LayerZero Labs has a whole long slew of things that it's building around the protocol to make the protocol accretive. The protocol itself is its own thing. It has a message gets sent, you have groups who are attesting, and they might charge, like if you're going to use Google Cloud to validate, then Google Cloud might charge you, 5 cents or 10 cents or 50 cents or whatever they want to charge. All of them set their own fees independently. If you're running it yourself, you can set it for free, or you can charge your users. You can do whatever you want. There's the execution side. And then the protocol has an underlying fee switch that can be turned on that basically is bounded by up to 200% of what the executor and the DVNs, which are the verifiers, charge in aggregate. And so the reason there is a bound, and I think it's very important, the reason there is a bound is if it wasn't, then the fee switch could be set to effectively unlimited and censor the entire network, right? So it has to be bounded. And what it also means is for certain financial institutions, if they want to run all of the infrastructure themselves and do 100% of it on their own, then the fee would be effectively zero because the verifiers and the executors would be charging zero, right? There isn't an enforced fee in the underlying technology. There is only a fee if you are using sort of external parties that are aggregating fees within the network. And so right now, there isn't anybody who runs the entire full stack themselves. Everything is run external to the network. And you can think on a per transaction basis, you're talking, depending on the chain, it's really based on gas is what drives a lot of it, because a lot of this is a markup on the gas that's being spent. But if you're on Ethereum and Ethereum's charging you $3 to $4, you might be charging 25 to 50 cents that the protocol would capture. So the long-term vision of the protocol is, listen, you're effectively reinventing TCP/IP here. If you think this is the way the technology moves and that all information moves across blockchains, across all of these networks, the protocol itself has the ability to charge a fee on every single message that's ever moved across the internet, effectively.
Yeah, and it gets to stay agnostic. It gets to be a protocol, and it feels like you've designed that from first principles. And speaking of first principles, the first principles of podcasts is I have to thank our sponsors. So I'm just gonna do that right now, and we'll come right back to close out. This episode, if it isn't already obvious, is sponsored by our friends at Visa, the leader in digital payments. Visa's Tokenized Asset Platform, or VTAP, uses smart contracts and cryptography to help banks bring fiat currencies on-chain, whether it's launching a stablecoin or deposit tokens or something else. VTAP allows financial institutions to issue fiat-backed tokens, improving financial efficiency and enabling programmable finance. Check out the links in this episode's description to express your interest in VTAP. Alrighty, thank you to our sponsors. Bryan, just a little change of gear here before we close out, which is I didn't realize your background, you were a machine learning engineer, and, like AI and crypto has been kind of a big topic for us. But, there are a lot of projects just slapping the word crypto on things, but then there's also like Airbnb for GPUs, and there's kind of agents and that sort of stuff, and all kinds of stuff going on. What's your perspective on that? Because again, as LayerZero, you kind of act as this like Switzerland type of model where you get to see a little bit of everything. What are you seeing from your vantage point?
Yeah. So it's been very interesting to see the convergence of two worlds, right? So I spent a long time. I spent almost 8 years in AI, and originally it was just early on. It was fun. I was building models. I sold the models to a bunch of the pro baseball teams. But eventually, like my last academic paper that I published with Noam Brown from Facebook AI Research, and Noam Brown is now like the creator of the O1 model at OpenAI, at ChatGPT, right? And so this has been like the really transformative model of moving things into actually sort of transitioning thinking and having it not just be training time, but inference time compute. And so it's really been interesting to see something I spent so much of my life on now become so large, and then this conversation around the convergence. I've actually been like the dissenting bear for a long time at the intersection of the two. I think there's a lot of things that don't make sense. I don't think an Airbnb for GPUs model is ever going to be successful against, on it, like just against economies of scale. You look at running nodes, running it like it's so hard to compete when Google and Amazon and all these big groups have like a third of your CapEx cost, and a third, your OpEx cost is just, everything is going to be driven down to basically the cost of electricity in a point where it's efficient. You've seen this with every form of mining, with Bitcoin mining, with all types of miners. It all basically, if you're at 3 cents a kilowatt hour, you're doing great. If you're at 6 cents, you're okay. And no consumer at 10 to 14 cents is even able to compete at all. Like it's just all gets industrialized basically. And so that model I've never found super interesting. I do find the agentic model very, very compelling. And I think it really comes down to a world of, I think DeepSeek was a very interesting moment. Maybe I'm getting a little bit too technical, right? I think DeepSeek is a very interesting moment because it shows that you can create something that costs significantly less. It really shows there's a heavy commoditization of models. I think there's a lot of discussion now that, hey, maybe the model piece itself is going to get heavily commoditized over time. So Llama, DeepSeek, all of these show that. And the question is, if all of the models and all of the fine-tuning of the models for what is, your hyper-specialized lawyer and accountant and everything, and that you might be using in the future for these agents that do very specific things, your travel planners, your assistant, whatever it is, if they all live purely in OpenAI and ChatGPT land, hey, maybe it's just going to be Stripe on the back end, and you're just, you're going to find a way to basically do this efficiently. Now, it's kind of a problem in the current world of microtransactions. I think that's like a thing that is kind of a constraining factor in some of the traditional markets now. But if it is unlikely that the end user, the consumer, is going to give the agent that they're using, their own assistant, who's going to go fulfill something. Hey, I want to book this appointment. I want to do this. I want to do that. If that thing doesn't have access to their credit card, to their bank account to be able to spend, what does that actually look like? And I think that is the world. These agents needing to go out and fulfill a task. And in order to fulfill that task, they might need to go talk to a booking agent and this agent and that agent and do all of that. And how do they?
You start getting into cross communication and cross authentication, and you might need some sort of abstraction layer to do all of that. Listen, I could sit at the learning tree for the rest of today trying to learn more from you, because you are at the intersection of so many things, literally as LayerZero. But that is all the time I have for today, and I do have to run, unfortunately. So Bryan, where can people find out more about you and more about LayerZero?
Yeah, if anything LayerZero, you can just find at LayerZero_core on Twitter, or LayerZero.network online.
Thank you so much. And Cuy, how about you?
On X at Cuy Sheffield and visa.com/crypto.
And you'll find me at SY Taylor, or look for fintechbrainfood.com. And with that, we hope you'll listen again next week. Thank you, and bye for now.